Welcome to this explainer. I am absolutely thrilled to have you here today because we are going to unpack the invisible network hero that you and I rely on every single day, completely without realizing it. We're talking about DHCP. Our goal today is to explain in detail, but using simple words, exactly how servers and clients talk to each other.
Okay, let's dive right into our roadmap for today. First, we'll meet the network hero. Second, the DORA conversation. Third, leases, ports, and rules. Fourth, setting up a server. And finally, number 5, troubleshooting common issues.
Section 1. Meet the network hero. How devices actually get online.
So before we get bogged down in heavy technical jargon, I want you to just imagine having to manually manage a massive network. How does your laptop actually instantly get online when you click a Wi-Fi network? You just select the network, maybe punch in a simple password, and boom, you're browsing the web. You don't have to type in some complicated IP address to identify yourself. It just magically works. But how?
Well, that magic is DHCP, which stands for Dynamic Host Configuration Protocol. In simple words, it automatically assigns IP addresses and essential network settings to client devices on a network. Think of DHCP as the ultimate, highly efficient hotel receptionist. When you walk into a hotel, you don't pick your own room, right? The receptionist looks at what's available and hands you a key, along with directions to the pool and the gym. A DHCP server does exactly that for laptops, phones, and desktops. It hands out IP addresses, subnet masks, gateways, and DNS servers entirely automatically.
Now, to really appreciate this, you kind of have to look at the alternative. Without DHCP, we're stuck using static IPs. That means a network administrator literally has to walk up to 500 laptops and 100 phones and manually type in a fixed IP address for every single one. It is a total administrative nightmare, and human error almost always leads to duplicate IP problems where two devices end up fighting over the exact same address. But on the other hand, we have DHCP. It's automatic, it's dynamic, and it makes centralized management infinitely easier. The devices just connect, and the server does all the heavy lifting for us.
Section 2. The DORA Conversation. The 4-step interview goldmine.
If you're an aspiring IT professional, you're going to want to listen closely here, because this entire DHCP process is absolute interview gold. It works through this beautifully simple 4-step conversation called DORA. That stands for Discover, Offer, Request, and Acknowledge. It's basically a structured negotiation between your device, the client, and the network's DHCP server. Let's break down exactly what's being said in this negotiation.
It kicks off with the D, Discover. Your client device connects to the network, but it doesn't have an identity yet. So it essentially stands in the middle of a crowded room and just shouts, "Hey, is any DHCP server available?" Technically speaking, because it has no IP, it uses a blank source IP of 0.0.0.0 and broadcasts this message out to the destination 255.255.255.255, which is just network speak for everyone on the local network. And this brilliantly leads us to the O, the offer phase. The DHCP server hears that shout across the room and replies back saying, "Hey, I can give you IP 192.168.1.100. But it doesn't just send the IP. It packages up the whole suite of network settings. It sends the offered IP, the subnet mask, the gateway, the DNS server, and importantly, the lease time. Basically, it's telling the device exactly how long it's allowed to keep this address.
Finally, we wrap up with the R and the A, Request and Acknowledge. The client looks at the offer and shouts back to the server, "Awesome, I want this IP." That's the request. The server then finalizes the handshake by sending the acknowledge message. "Okay, use this IP." The deal is totally done. The client configures its network interface and communication on the network officially starts. 4 incredibly simple steps: Discover, Offer, Request, Acknowledge.
Section 3. Leases, ports, and rules. The technical details.
Now, what's really interesting here are the specific communication channels or ports being used. Make a note of this because it is a massive interview question. The DHCP server listens on UDP port 67, and the DHCP client listens on UDP port 68. You might be wondering, why use UDP instead of TCP? Well, it's because UDP is super fast, very lightweight, and has absolutely zero connection overhead. Remember, during that discover phase, the client doesn't even have an IP address yet to form a complex TCP connection. So it relies on the sheer speed and simplicity of UDP to just get the message out there.
We also mentioned earlier that an IP address isn't yours forever. It's literally just a temporary lease. Let's say the lease time is set to 24 hours. At hour 0, the lease begins. But here's the cool part. Your device doesn't wait until the very last second to ask for more time. Usually right around the halfway mark, so 12 hours in this case. The client will silently, right in the background, send a request to the server to renew that IP. If the server agrees, the timer resets. But if it's not renewed, at 24 hours the lease completely expires, the IP is stripped away, and your connectivity is lost.
To fully grasp the whole DHCP package, let's quickly translate these core networking terms into plain English. The gateway is simply your router's IP. It's basically the door your data uses to leave the local network and go out to the internet. DNS is the internet's phone book. It resolves human-readable names to computer-readable IPs. The MAC address is the permanent physical hardware address actually stamped right onto your network card. And the scope, or pool, is simply the total range of IP addresses the server is allowed to give out. The total number of hotel rooms available.
But hey, what happens if the DHCP server completely crashes and goes down? Well, the whole DORA process fails. Your client can't get an IP. If you're on a Windows machine, the operating system basically panics a bit and gives itself what's called an API-PA address, which always starts with 169.254. Linux systems might do something kind of similar, or they might just assign no IP at all. Either way, it means your network connectivity has failed. You are not reaching the internet.
Section 4. Setting up a server. Practical configuration in Linux.
All right, let's get our hands dirty. Once you install the DHCP package on Linux, you configure it in a simple text file called /etc/dhcp/dhcp.conf. The absolutely most critical line in that entire configuration file is the range declaration, like range 192.168.1.100, 192.168.1.200 semicolon. This is where we literally define the pool. We are explicitly telling the server, look, you are only allowed to hand out an IP address between 100 and 200. Everything else is totally off limits.
The server also needs to know exactly what extras to send to the client. In that exact same config file, we set the default lease time to define the duration of the lease. We use option routers to tell the client the gateway IP. We use option domain name servers to hand over the DNS info, like 8.8.8.8. and option subnet mask to find the actual network boundaries. By typing just these few lines, we're literally automating the network configuration for hundreds of devices. It's that powerful.
You can also pull off some pretty advanced tricks. Take a DHCP reservation, for example. Sometimes you want a specific device, like a network printer or maybe a security camera, to always get the exact same IP address so people can easily find it. In the config file, you simply tie a specific fixed address directly to the physical MAC address of that printer. Every time that specific MAC address asks for an IP, the server bypasses the random pool completely and hands it that exact reserved address. Oh, and it's definitely worth noting DHCP relays here too. Since those discover messages are broadcasts, they normally get blocked by routers. A DHCP relay uses an IP helper address to actually forward those requests across routers to a central server.
Section 5. Troubleshooting common issues. What to do when things go wrong.
All right, rapid-fire checklist time. If a client just isn't getting an IP, run through these steps. First, check the basics, the physical cable or the Wi-Fi connection. Next, ensure the firewall isn't accidentally blocking UDP ports 67 and 68. Verify that the DHCP service itself is actually up and running on the server. Finally, check the client's interface config. In Linux, make sure the boot protocol, or boot proto, is explicitly set to DHCP so it knows it actually needs to ask for an address. Another huge issue to watch out for is an IP conflict. This nightmare happens if you accidentally manually assign a static IP to a server that is also sitting inside the DHCP server's automated range pool. 2 devices, 1 IP. It is total chaos.
Now, if the DHCP service itself just flat out refuses to start, usually it's a syntax error in your config file, or maybe you specified the wrong subnet. Your ultimate administrative weapon here is the system logs. In Linux, just run the command journalctl-u dhcpd to essentially read the server's personal diary. This will tell you exactly why the server is unhappy. On the client side, you can use a network sniffing tool like tcpdump listening on port 67 or 68 to literally watch the discover and offer packets physically fly across the wire in real time. It's super cool to see.
Well, we have covered the what, the how, and the why of DHCP. From the sheer automated efficiency of DORA to those UDP ports, the lease timers, and some practical Linux troubleshooting.
It's a brilliant system designed to make massive network management entirely invisible to the user. But before we wrap up this explainer, I want to leave you with a quick thought experiment to test what you've learned. Think about the smartphone sitting right in your pocket. If your home router suddenly lost power this very second, the DHCP server is effectively dead. So, how long would it actually take for your smartphone's current DHCP lease to silently tick down and expire, leaving you entirely disconnected? The clock is always ticking. Thank you so much for joining me, and keep exploring the incredible systems that keep us all connected.